You need to understand what's going on first before you use the calculator, because if you put something in there and it looks right but it's not, you fools, you're wrong. You just lost all those points. So you want to be able to understand what's going on first. So just for the recording, we're working with logarithms. We're taking exponential equations. Some base number to an exponent is equal to an answer, which we've done before. That could change into a logarithm, which is a very different question. In this case, we're not looking for an answer. We're looking for an exponent. Beautiful. Thanks for playing with me here. So this would be log base and then the answer, and that would be a call for an exponent. Like in this case, log base 2 to the 8th, we're asking 2 to some exponent gives us 8. That exponent happens to be 3. So ask yourself the same question here. 5 to some exponent gives me 125. That answer is 3 as well. 5 times 5 is 25. 5 25s is going to give you 125. Okay.
Wait, so.
Wait, so what?
Never mind, you just confused.
I confused you?
Yeah.
What do you mean, why? On this one?
It said,
I just repeated it all for the recording.
oh, okay.
But for this one, the one you're doing, this should be 3.
Alright.
Right? Good. Okay. All right, so let's talk about logarithms, yo. Let's talk about logarithms. Do you remember when we were doing the quadratic? Why is my red marker gone all the time? You guys remember those quadratic equations we were working with? Y is equal to a times x minus h squared plus k. What does a do to my function?
Isn't it the stretch or compression?
It's my stretch or compression, right? Stretch or compression. When do I know it's a stretch?
It's over 1.
When it's bigger than 1. It's a compression when
It's
lower than 1.
less than 1 but
Greater than 0.
bigger than 0. And if I put a negative up front, Jose, what happens? It flips, right? So A, it has those properties here. What does H do? It moves it left to right. If it's now also be careful because there's that built-in negative, right? So if it's a negative, you're still moving to the positives. If it's a plus, that's moving to the negatives because negative makes a. So just refresher here. What does K do?
Isn't it
Up and down. Moves up and
the
down.
Y?
Miracle? What's K do?
I'm sorry, I was listening.
Oh, I thought you were excited. You're like, me.
Waving at myself.
Oh, my bad. I thought it was like, pick me. Pinyom. What's K do?
It's up or down.
It does the up or down, right? In this case, if it's plus, it's going to go up. If it's minus, it's going to go down. Remember all that stuff, Deja? Up, down, left, right, stretch, compression. So, what we're going to do is we're going to work with the parent function in this case. So I want to write this guy for you. We've got y is equal to log base b of x. What did a do before? What was the a value doing? It's a stretch compression, right? We still have a. It's right here. Guess what that does to my log function? What did it do before? Guess what it does now? Stretch compression. Let's put a plus k out here. A plus k out here. What did k do before?
Moves up and down.
Moved it up or down. Guess what k is doing now? It's moving my function up or down still. You guys remember how k or x or the h was inside with x? Same idea here. Minus. Oh, that's weird looking, isn't it? Here, look at this one. Look at this one, because there it is. It has all of them. Still has a, still has h, still has k, and they're still doing the same things. It's not changing, and it's not going to change. They will always be those things. You guys have that? Can I get rid of this? Jocelyn, you good? Yes? Sure? Okay. I want to show you guys something. So we've been working. I want to put, no, not tan. You guys haven't done that yet. Let's do, no, I don't want to do log yet. I'm going to do 2, no, let's do 3 to the x. 3 to the x. You guys remember what shape this is? Graph-wise, what's it look like? Is this exponential growth or exponential decay at least? Good. And what does the shape look like? Can you guys do the shape with your hands? It looks kind of like this, right? It's going to grow, and then start going fast at some point. No? Here, I'll show you a picture. Graph. So it's kind of getting close. It's really, really close, and it's going to shoot up. Okay, that's exponential growth. Because it's growing. And even if you went backwards, you can think about it as decay, right? Half and half and half and half of that, half of that, half of that. This thing, even though it looks like it's on the line, is it really touching it? No. Okay. I want to make sure that I'm in square 5. Because that's going to square everything up. I want you to think about the logarithm as the inverse function of the exponents. And I think we already said that at the beginning, right? If we did log, where's log at? Math, log base. What base do I want? 3. Why do I want 3? Because that was my base before. So there's log base 3. Then we're going to throw x in here. And then we're going to graph that. What are you guys expecting to see? I want you to turn to your neighbor and see if you can think about what you're expecting to see. If this is the inverse of the exponential function, what should the inverse look like?
I think it's gonna look like this.
Like what? Where? Oh.
Or actually not that. The opposite, like instead of going like that, it's gonna go like that.
Mm.
It's gonna flip.
Instead of doing this,
Like,
it's going to do what? Flip? Like this?
No, like a reflection.
Turn around.
A reflection? So like this?
Yeah.
Well, that's decay, isn't it? That's exponential decay. It's getting smaller. Not the inverse of it, right?
So
Someone said a word right now. Someone said reflection. Whoever said reflect, no, I heard it over there. I'll steal your words. A reflection is good, but we're going to talk about that in a little bit. Now head up. You guys ready? Now, understand this. Does this look like that?
No.
It's missing all this, isn't it? The computer's stupid. The computer's really dumb. The computer, at a certain point, says, you know, the difference here is almost 0, and it won't do it anymore. But it really does look like that. Oh, that was pretty good at the end. So that's what it looks like, okay? So whoever said it's a reflection, it kind of is, but it's a reflection on a specific line. And that line is the line y equals x. You guys remember that bad boy? What does he look like? This was the first function you guys graphed in Algebra 1. Probably pre-algebra. Y equals x. It's just a line, right? With a slope of 1 and a y-intercept of Deja. You guys see that? The reflection from this over that line becomes this. And that's what we're looking for when we want to do inverses. Right? No. All right, cool. Let's move on.
Can I write that backwards?
Right, what?
Like
This? Yeah. Trying to blame Anastasia. This for me? Oh, no. Can I move on? Okay. Write this in logarithmic form, please. Write this in logarithm form. That's how you switch back.
So are you guys still doing swing? Yeah, that's what I was thinking. I was like, man, if you guys still doing swing, let's why don't you guys go to like a rec center or something?
¿Estás un cuaderno, mijo? ¿Estás un cuaderno?
Maybe.
Oh my
I remember that one.
goodness.
Last time I remember that
I
one.
have news for you guys.
No.
No, this is like the funniest thing ever.
It's like a no referral
So-
thing, but it had like 5 referrals.
Y'all love them Cheetos, right?
Oh, yeah. Huh?
That dust, it has a name now. Frito-Lay has named that dust.
What is it?
It's called Cheeto.
Cheeto?
Cheeto. Cheetle. Cheeto. So don't be putting that Cheeto on your homework tonight. You eating your Flaming Hots.
They really kind of
They just, yeah, well, I just saw the articles today, so. Like, everybody calls it Cheeto dust, right? Oh, you got that Cheeto dust? But it's not Cheeto dust. The name is Cheeto.
Yeah.
Why would they spell it like that?
I don't know. It's not like a battle with me. You know that Cheeto in my shirt?
No. There are 3 desks for moving. This one is
Right, but you want to here, let me. Yes, it's correct. But imagine this is my line. It's going to be log base 2, 100 equals 10. Like that. Okay? Okay. Waterfalls. Hairspray. Gosh, I will get it one day. I got so many of them out. It's not even funny.
Waterfalls.
Hairspray. Good. I wanted to write on a line over here because you need to see where the numbers go. So you should have gotten log base 2 100 equals 10. Notice that the 2 is like a subscript. It's a subscript. So it's log base and there's a little number down below. That's called subscript. That's the 2. This is my answer. This should be my exponent. This is the exponent I'm writing. I see a lot of curly faces going, what? What's the question?
I got that.
I'm checking your answer.
You're checking my answer? Good.
No, you're wrong.
I'm wrong?
Yeah.
It's supposed to be 10 at the base.
Yeah.
Oh, yeah. My bad.
I thought I was tripping.
Got you.
Ooh, look at you guys. I've been thinking about that Cheeto too much.
So what?
Good looking out. All you guys with the curly faces, good job. Do it again. You're wrong. I'm the authority here. No, I was wrong. You guys are right. Ready? Try it again. Change this one into log form, please. Change this one into log form. Si quieres un cuaderno, tío. Un cuaderno para que hagas notas. No puedes andar en el teléfono. Yo sé que es bien el teléfono, pero
I'm checking my work.
te vas a tener que trabajar un poco. No van a casa, güey. Lo vas a estar And you know why I remember? Because all this like look at all that. Yeah, Cheeto. I don't know.
Let me get a job. I can.
It's gonna be fetal.
Fun
Or
yule.
funnel.
Fun yule.
It's gonna be funnel.
Fun yule.
It's gonna be funnel. Put it back there.
This is in the way.
Sitting right inside that.
Make this.
Hopefully I didn't make a mistake this time. So this is what you should have. Log base 381 is equal to 4. Good? One more time. Boom.
We did that.
Did we? Okay, then skip it. Let's move on. Okay. Well, if you already did it, why are we going to do it again?
We didn't do that.
Just for practice? Okay.
Well, we didn't do that.
I'm forgetting. We actually did feel it.
You feel it in your bones?
I don't know who
Stands up and starts clapping.
I don't know who said I had the best thing.
Give us like a minute or two.
Everyone's like,
That person got a raise.
That's it. That's it. That's it like that.
it's like, don't tell me.
What did you do over the weekend?
We had to go shopping, so we went to Phoenix. And we got some tortillas at the Mexican store. And then yesterday went to my dad. And I almost shaved this bad drop my face. I almost took it off. I was like, maybe
You
not
look
tomorrow.
at it?
Huh?
You look at it?
Nah, because I see you know, like, nah, I don't want to look like that. I'm just kidding. It looks good. You look like you're like junior high again.
I know I actually look like a student.
You always look like a student.
When you
Who knows? When does this
When you-
come off?
I don't know. Someone told me to do the Wolverine thing.
No, just keep the mustache.
The mustachio with my curls.
Yeah, look like Mario.
I had it like that before.
Yeah, just keep a mustache.
I'll show you a picture.
That'd be dope.
I used to always have a mustache.
Yeah.
I look hot.
Okay. So for this one, you should have log base 6,
Yeah. Great. 6 and 36.
and the answer would be beautiful. You guys are good. I don't have to spend much time on this. All right. So evaluating logarithms. How much?
3.
How much?
Doesn't work.
3.
Yeah, actually. What if something doesn't work?
Yeah, it doesn't work.
It will always work. So I didn't want you. So. I didn't want to show you with the calculator. Some of you guys already figured it out, but there will be a number, and what's it going to be?
1.666.
So 1 1/3. No, you said 6. So 1 2/3. So that's 1 2/3. So it's 0.66666. So if you plug that into your calculator, you got 1.666, right? That's equal to 1 2/3. So if you have a calculator, if you don't have one right now, don't go grab one. You should be used to getting them as you come in. But I do want to show you how to get that on the calculator. Let me clear that. Okay. Do you guys notice there's a log button up here in the front?
Yeah.
We'll talk about that one later on. You don't need to use it right now. But if you go to math and you push up, you're going to see this log base. That's the one you want. Because log base is going to let you put that number at the bottom. See that? What was it?
5 and
Deja, what was it?
8 and 32.
8 and 32. And of course you hit enter. There it is. Now, when you do this button log, it's not going to let you put anything down there. So you only want to use this one in special cases. When I was in college, we didn't have this guy up here, so we had to do some fancy stuff with this guy. I'll tell you what this is. But before we do that, I'm going to preface some things. If we do the square root of something, what's the index? 2. It's understood, right? We don't write it, but we know that. If we have x, what is the coefficient on x? 1. It's understood. We don't write that. Because of this guy, this does have a base number on it, but what is our base system in? Do you guys know? Our base system isn't 2. We're not binary, bro. It's base 10, right? You guys remember counting base 10? So when you do log base with no base there, understand that it's a base 10. So if there's log with no number down below in the base, it's going to be a base 10 number. Questions on that? So when should you use just log by itself? Now when you got log base. Yeah, it's becoming kind of obsolete, but that's where it's been. But I want you to know what it is so you understand what's behind it, okay? So log with no base is going to be base 10. We're good? All right. I don't want to do that. You guys are going to get scared here. You want to see that again? So I'll just talk about this problem. There's been a lot of earthquakes lately, right? And they're always talking about the scale it is. It was a 5.0 or the magnitude, okay? And then you never heard of earthquakes?
I said what it was, and then I said magnitude, he laughed at me.
I did not laugh at her.
When you said scale, I said.
You were correct. I was incorrect. But there's a formula that's used to calculate it. It's right here. Do you guys see it? You might want to write that down because you're going to need it. That's an I. I sub 1, I know. I sub 1, I sub 2 is equal to magnitude 1 minus magnitude 2. You're welcome, courtesy of Munoz. Put in your backpack. So anyways, what I want to talk about the magnitude. Sometimes you see, oh, there was an earthquake, which was a 5.5, and they're like, oh, the next one was a 5.6, and then people think, are they really that different? A 5.5 versus a 5.6? I haven't either, but we're just talking about it. Do you think that a 5.6 would be that much worse than a 5.5? Not really, right? Because it's what, like a point off? But notice that what you have here is the logarithm of a ratio. So in fact, the change in 1 decimal or even like a tenth of a decimal is a big difference. Once you start getting up higher to the higher values, it really is more destructive, even if it is just like a tenth of a decimal. Okay? All right. So here's what I want you guys to do. You have a calculator in front of you? If you don't, go grab one. You're going to need it. Put it in your backpack, Deja.
Oh, yeah.
Put it in your backpack.
So good. Thank you.
Go ahead and plug that into your calculator. I want you to figure out what the domain and the range of that thing is. The domain and the range.
How do we do that?
We'll plug it in first. How do you do that?
It said,
You're here, right? Are you here? Or are you guys in y equals?
what? I'm at neither.
Wait, we have to do a white.
Yeah, well, you want to push y equals here.
What were the numbers?
I don't know.
What was the equation?
Deja, pick your head up. Log base 3x. So where are we going, math? Log base 3x. Okay? And then once you have that, you're going to push
What?
graph.
What is Yeah. What is it for?
What's what for? It's just a hole. You see how this has a hole right there? That's where the projector used to be. I just like messing with people.
That's not
It's hilarious.
I was something you're gonna drop out of it. I was sitting directly up there.
But they don't fall out of it. But they didn't want to give you a new file either. I was
But they won't.
You should get something that looks like this.
No.
No?
Mine looks so weird.
Oh, you need to zoom normal. Go 6. Which is standard. You can just push 6 too.
Oh yeah, that's not.
See, yours is the same. Okay, I don't know. Mine is the same thing.
Oh, your stuff was in.
Yeah.
What?
Of course not. I got it.
Why?
We have games there.
He's just gonna try.
No, seriously, we have football games there.
Log base 3x.
Yeah.
I've never been so excited. What time is it?
I always wear this sweater.
You guys are good? You guys are good? Here, put that away. So everyone turn on the background.
I lost the
Alright, give me thumbs up if yours looks like mine. Good, good, good. So, question C logically goes down to what is the domain and what is the range. Okay? Now, think back to algebra 1. What is domain? It's all the x's, right? So, Which of these is my x? The one that goes up or down or left to right?
Left to right.
Okay. Is my function anywhere over here? It's not, right? What's the smallest value that I could be? 0. So I'm going to go, can I be 0? No, not for this one. I'm going to get close and closer to that line, but I'm not going to be 0. So my domain is going to be a parenthesis, 0. Deja? Don't do that. Thank you. Oh, you're smelling the desk? It smells good. And then how high does the x value go? How high does this go on x's? How far can I go this way? To 5, 10, 20? To infinity? So you're going to go 0 to infinity is my domain.
Is that a butterfly for everyone?
Yes. It's a flutterby. It's a bow tie.
It looks like
You guys got a domain? Range. How low does this function go?
Infinity.
It goes down to, it comes down from negative infinity, right? So that's going to go from negative infinity. How large will it get? It will also go to infinity. Good.
Whoa.
So there you go. Which one? You what? A face mask? Sound like a what?
Oh, I do that. I be doing that in my
It smells like cheddar. Is somebody eating like Ruffles?
It's that Cheeto dust.
Who's eating Cheetos? Is it over there? Someone's having some like cheddar Ruffles? Oh! Some sharp cheddar. I'm just kidding. It doesn't even smell like nothing. I just want to say something. Someone dropped their Cheeto over there.
No, your food was like orange.
No, I don't.
No, I'm saying like this like orange and white cheddar.
It's like it's fun to be dressed.
Okay.
Really good.
Hairspray. Before we get this crazy, I do want to, let's start off with something smaller. So we've got y equals log base 3 of x. You guys saw that looks like, it looks something like this, right? Okay. This is always going to cross the point 1 comma 0. So that point right there is 1 comma 0. Just like the exponent always crossed 0 comma 1. Remember that it gets flipped? Okay? So let's talk about some stuff here. If I want to move this left to right, what do I need to change? If I want this function to move this way, here, actually let's do this. I want my new function to cross, well that's horrible, but I want it to be at 5 comma 0. How do I change my function so that it's, you what? How many? 4. It moved over 4 units, right? So it will look like this. It will look like that. So there's my function there. David? Y'all can't have no turkey no more. Y'all eating turkey or something.
What does that even mean?
Huh?
Oh,
You knew that, right?
I didn't know that.
Yeah, turkey has some, what is it? It's not, I don't know if it's a hormone, it's a, what's the word I want? I don't remember, but hormone makes sense. It's got something in it that once you eat it, you get sleepy.
it's like comfort.
No.
I think it's scared of
That's the idea.
I want you to write an equation, a new equation, same thing. But I want this one, instead of to be here, I want it to go, and I want it to cross, I want this to be at 4 comma 0. I want it to be at 4 comma 0. So the red one is now at 4 comma 0. It went up how many units? 3. Write me an equation that represents that, please. Ándale, sí se puede. Go this way this time.
Is it plus 3 or plus 3?
Not in parentheses.
Not in parentheses? So then 3x plus 3.
Because if you put it in the parentheses, that's
Side to side. Oh, okay.
For that, it's gonna be
Dile que te ponga un supositorio. Dile, ¿ves qué hace? Recording.
When does parallel start?
I think you guys make your own practices.
Right, but when?
Whenever sign-ups are over, whenever you have your team,
Which is when?
sign-ups are over Wednesday.
Oh, okay. So
alright.
Practice Thursday. We're not.
Huh? When's the game?
I don't know.
That's a race to the left.
Yeah, but how many people do we have?
They're,
How many people do we have? Only two.
Would it be like?
Little guys.
um,
Yeah, Courtney didn't tell me though. So I went there on Friday and it was free.
They're up front.
you know what? I wasn't worried about you.
Oh, right, but you were. You're like, Ben, so why aren't you the powder puff coach? Did you or did you not? So you were worried
I
about me.
encouraged you,
So
Ben. You
were
didn't have to
worried
do it.
about
I
me.
just encouraged you.
No, you pretty much pressured me. Like, aren't you the powder
Peer
puff?
pressure.
And I was like, why would I be? You're like,
Okay.
you don't have one?
I just offered it to you.
Y equals log base 3x plus 3. Please be careful. Do not.
Girl, you dumb.
I get it all.
I almost ran into the scissors.
I see what you're trying to do.
So you don't put parentheses.
Thank you.
You almost headbutted her.
I almost had butted the scissors. You didn't see my eyes get all big? She had them like this. Okay. Hairspray.
Oh my god. Shut up.
Please be careful when you're writing your K's versus the H's.
So for that log we just did, you wanted to go up, right?
Right.
And then why is it 4, 0? Wouldn't it be 1, 4?
Because it's already their one unit, see? Oh, no. That's wrong. You're right, that's wrong. That should be 1, 4. It should be 1, 4, right? I am. And then this should become 4. Okay. Guys, before we go, don't put the notebooks away. You're going to want to write this down. Please be very careful. Notice that those two have the same type of formula. The only difference is that this one's in the parentheses. This one's outside of the parentheses. With the parentheses, that's a side-to-side shift. Outside of it, it's going to be a vertical shift. So please don't make that mistake. That's either up versus to the right.